Alright, areas of irregular figures, 11.4. Objective, students will be able to find areas of regular polygons and circles. Actually, I think that it's irregular. Irregular, and we already did circles, so sorry about that, little typo in the objective. So we're going to look at irregular figures, and the important thing to know is that the area of a region is the sum of its non-overlapping parts. That means that you can always just take a figure and chop it up into smaller parts, and the sum of those parts is the area. That's really helpful because we have weird figures like this guy. Okay, it's not a known shape, but it does have a lot of smaller parts to it. Like we see that this is a rectangle. It looks like we took a triangle out of there, and we have a half circle. And so I look at this and I say, well, this is a rectangle minus a triangle plus half of a circle. And now I'm just going to plug all this stuff in. My rectangle is, let's do this one color at a time. My rectangle is 19 times 6, because that's the base times the height. The triangle, a little bit trickier because they show us the dimension of the triangle down here. Well, it's an equilateral triangle because it's 6, 6, and this whole side is 6. So it's an equilateral triangle, but if I was to draw the height in right here, we would have a little 30, 60, 90 triangle, which means that if this side is 3, this height here has to be 3 rad 3. So that means that I have a base of 6 and a height of 3 rad 3, so I can find the area of this guy. So the triangle is minus, we're subtracting the triangle because we took it away, minus 1/2. The base we said was 6, and the height we said was 3 rad 3. And now lastly, let's add the circle. Well, let's take a look at the circle. We have a half circle here with a radius of what? Well, over here we see straight up and down is 6. So that means right here is 6. That means the radius must be 3. So let's just plug that in. Remember, it's 1/2 of that circle. It's not the whole thing. So 1/2 of pi, and then r, my r is my radius, squared. Okay. Now we just need to simplify this down. So 19 times 6, I believe that is 104. 1/2 times 6 is 3, and 3 times 3 is 9, so this is minus 9 rad 3. And over here, I have 1/2 of 3 squared. Well, 3 squared is 9, and half of 9 is 4.5, so I could write plus 4.5 pi. Now, I could not simplify this anymore without using a calculator, so this is actually what we would call an exact answer. Exact. But if I needed to, I could plug all this into my calculator. 104 minus 9 rad 3 plus 4.5 pi, and it'll give me a decimal answer. So let me check and see what that would be. Actually, there's a typo here. This is not 104. Sorry, this should be 114. Sorry, I was just doing that in my head and I messed up. So there you go, 114 minus 9 rad 3 plus 4.5 pi. Alright, so when I get all that in my calculator, it comes back with 112.55 roughly. I had to round, that's why it's not exact, because I had to round right here. Units squared. So there you go. That's how you do that first type of problem there. Just break it up into parts that you know. I like to write a little shape formula here just to see like what am I going to do to find the area here. And there you go. Let's go to the next problem. Alright, this next problem says Melissa's dining room table has hardwood around the outside. Find the areas of wood around the edge of the table. Okay, we just want the area of this wood edge. We don't want the area of the table, just the wood edge. So let's take a zoom in here. It looks to me like I have a rectangle here that's 60 by 3, because they tell me the width here is 3, and here is 60 by 3. So I have two rectangles that are 60 by 3. 40 by 3, 40 by 3, so 2 rectangles that are 40 by 3. And then I have 4 little corners here that are all quarter circles. And when I combine those 4 together, it actually makes one circle with a radius of 3. So we could kind of spell this out in a formula that looks something like this. We could say, hey, I have 2 long skinny rectangles like this, plus I have 2 rectangles that go up and down, plus I have 4 quarters of a circle. Well, 4 quarters of a circle, obviously, that just makes one whole circle. So I have 2 rectangles going this way, 2 rectangles going this way, and then one whole circle. All right, well, the 2 rectangles is going to be 2 times 60 times 3, because those rectangles are 60 by 3, plus the 2 going up and down are 2 times 40 times 3. And then the circle would just be pi times a radius of 3 squared. Okay, let's figure this out. Well, 60 times 3 is 180. And 40 times 3 is 120. And 3 squared is 9, so we put the 9 in front, and then pi. And 2 times 180, that's 360, plus 240, plus 9 pi. And 360 plus 240, that's 600, plus 9 pi. Alright, that's my exact answer. But if I didn't know or if I didn't need an exact answer and I wanted a decimal answer, I could plug that into my calculator. So go ahead and try and plug in 600 plus 9 pi, and you should get 628.27, and remember these are inches squared. And here I would have put parentheses and then said inches squared. Okay, there's your answer. Alright, for this next problem here, I want you to find the area of this polygon, but I have it gridded out here, and what I would recommend that you do is try cutting it into shapes that you know, like look for triangles, look for rectangles, look for squares, look for trapezoids, look for things that you know, and first cut it into those shapes. Find the area of those separate shapes, and then add that area together. I'm going to let you guys try this on your own, and then I'll come back and finish it with you guys. Okay, now there's lots of different ways that you could have cut this shape up. I had some people who decided to cut this into 2 triangles here. Let me draw that a little bit better. 2 triangles and a rectangle, and then they added up those 2 triangles and the rectangle. I know some people who cut this into 4 triangles. There's 4 triangles there, and then they added up those 4 triangles. I know some people who cut this up. Let's see. What did some other people do? Some other people cut it up like this, and then for whatever reason, like this on this middle. So 2 rectangles and 2 triangles. But I think the easiest way to do this, all of those would work. They're all fine solutions. But I think the easiest way to do this is to just draw a little line right here from S to U. And now what we have is we have a triangle and we have a trapezoid. And so we just have to add up the blue triangle, and we'll call the triangle the red, or the trapezoid the red trapezoid. So blue triangle plus the red trapezoid. Okay, well, this is fairly simple, really, because we know the formula for a triangle is 1/2 base times height. Well, what's the base? Let's look. Well, here would be the base of my triangle, which is 1, 2, 3, 4, 5, 6. So that's 6, and the height just goes straight up and down. 1, 2, 3. So that's 3. And we could kind of simplify this. 1/2 of a 6 is 3, and 3 times 3 is 9. So the area of our triangle is 9. Alright, now let's do the trapezoid. Well, that's going to be 1/2 the height. Then I'm going to add the 2 bases together. So let's first find the height of my trapezoid. It's 1, 2, 3, 4, 5, 6, 7. And let's now find the 2 bases. Well, we already have one of them, right? Because it's the base of the triangle. That was 6 plus the bottom base. Well, let's check. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 6 plus 8. Well, that's half of 7, and 6 plus 8 is 14. Now, for me, mentally, it's really hard to, well, not really hard, but it's harder to do half of 7 than it is to half of 14. So instead of doing 1 half times 7, I know that I can multiply in any order, so I'm going to just do 1 half of 14. Well, 1 half of 14 obviously is 7. So I'm going to have 7 times 7, and 7 times 7 is 49. So I have a 9 plus 49, which is 58. And they didn't give me a units here, so I'm just going to say units squared. 58 units squared is the answer. Hopefully that's what you came up with. Alright, I'll see you guys on the next video.